Hi everyone, welcome to this class on force and pressure. I'm sure you've heard the term pressure in your daily lives, right? Like we have exam pressure or work pressure, but in this class we are going to be looking at what is the physics definition of pressure. And I'm going to make the concepts really easy for you. So friends, be sure to watch the entire video and I'm sure you'll find the concepts really easy. And guys, if you haven't checked out our website, do check it out. The website is minochaacademy.com and we have some awesome courses for you on physics, chemistry and maths. So guys, do check out the courses, and these are we have these courses where I'm taking live classes. There are quizzes and questions and lots of things for you to practice. So guys, do check out our website and also share it with your friends. And I'd like to let you know that we are getting close to 200,000 subscribers. That's right, guys. Minocha Academy family on YouTube is getting close to 200,000 subscribers. And I'd like to say a big thanks from the Minocha Academy team to all of you. And guys, do help us by sharing it to your friends. And really, guys, it's awesome to read everybody's comments. So welcome everyone for this live class on force and pressure. And let's dive right into it. So guys, we hear this term of pressure all the time in our daily lives, right? Like for example, you hear of work pressure, right? So work pressure or your homework pressure, right? And then of course you have your test or exams pressure, right? So you have exam pressure. So is this the pressure we are going to be talking about in today's class, guys? So is work pressure, exam pressure, is that the same as physics pressure? What do you guys think? So come on guys, what do you guys think? Is it the same? Is work pressure the same as exam pressure? No, excellent guys, excellent. Because as you know, these pressures are in our mind, right? So the work pressure, exam pressure, these are all in the mind, right? So as you can see, that these are all in our brains. It's all in the mind. This is not a physical thing, right? It's in our thoughts, right? Okay, and we should definitely avoid pressure and anxieties in our daily lives. But in physics, we are going to be talking about the real pressure, right? The physical meaning of pressure. So we are going to be discussing the concept of force and pressure in this class. Okay, and so what is the meaning of pressure? As you can see in the pictures here, can you see that when you are cutting a lemon with the knife, you're applying a pressure. So guys, if you take a look at this, you're applying a pressure here, right? We say while cutting, we are applying a pressure with the knife. Okay. And guys, if you take a look at this example, so when you take a pencil, right? So if you take a pencil like this, right? So here I have a pencil here with me. So if you pick up a pencil, you know that the pointed side hurts you. But if you touch the opposite side, right? The thick part of the pencil, it doesn't hurt you. You feel more, you feel hurt when you touch the pointed side. So why is that, right? Or if you take a look at this, right? So if you look at the example of the bag here, right? So in our school bags, we know that they have wide straps, right? So the shoulder straps are wide or thick straps. So why is that? How can we use physics to explain this, right? And if you look at the picture here, so here was the sharp pencil, right, that we talked about. And here you can see the picture of the tractor. So why do these tractors have such thick or wide tires? So can you see the tractor has thick tires, right? And if you look at this tank, okay, so guys, if you look at this tank here, because you know the tank rests on this long continuous chain. Can you see? There's a long continuous chain here. So why is the tank using a long continuous chain? That's right, guys. Very good. It's all about force and pressure, right? And pressure is going to be the main topic of today's video. So we are going to see what's the difference between force and pressure and how we can relate these everyday life examples with our physics knowledge. And I'm going to make the concept really easy for you. So guys, let's start with a simple everyday example. And if you guys have a pencil nearby, pick it up right now, okay? So, or if you're watching this video later, pick up a pencil, okay? And try this simple experiment. So make sure your pencil is sharpened like this. So can you see I have a sharp pencil here, right? And this end is obviously the back end of the pencil, okay? So guys, when you touch the pencil, right? If you touch it at this point, so here, if we mark it in the picture here, so if you put your hand here, right? So if you put your hand here, right? The hand, it hurts here, right? So you know that this side will hurt. The sharp end of the pencil hurts. But if you put your hand at this flat end, so let's say your hand is here, then it does not hurt, right? So this side, you know, it does not hurt the hand. Okay, so the sharp end feels, but note carefully, you're applying the same force, right? So when you're pressing your finger against this sharp end, or you're pressing it against this end, note that the force is the same, right? So let's say you're applying a 5 Newton force with your hand, right? So when you're touching this pencil, let's say for example, here we apply a 5 Newton force using the hand on the pencil. And similarly here also we apply a 5 Newton force here. So guys, you can see that force is the same. Okay, so force cannot explain. So force cannot explain why this sharp end of the pencil hurts more, right guys? But because the force is the same. So when you put your hand or your finger like this, right? So the force is the same here, 5 Newton, and this side also 5 Newton. But why is the sharp end hurting more? Excellent guys. I see a lot of you are writing that thing because you know the end is sharp, superb. And here the reason is basically the area is less, right guys? So it's connected to the area because the area is less on the sharp side. And here, you know, the area is more. And guys, you know, we call it the area of cross section because it's considered like a cylinder here, right? The pencil. So this side, the area is more. Okay. So it's not just connected to, so on this blunt side, right? Or on the back side of the pencil, the area is definitely more. Okay. So guys, we can see it does not depend only on the force. It also depends on the area. And that's why we need this another concept in physics. We need to define the concept of pressure. Okay. So guys, what is the meaning of pressure? As you can see here, pressure is defined as thrust per unit area. Okay. So this is the definition, and let's really understand what is the meaning of thrust. Okay. So guys, pressure is defined as thrust per unit area. And what does thrust mean? So I'm going to explain that to you. Thrust means a perpendicular force, right? Or force acting in a, or we can say force in a perpendicular direction. So let's write it that way. Thrust is force in a perpendicular direction. So force in a perpendicular direction. That is the meaning of thrust. And I'm going to explain that. And pressure is defined as this perpendicular force, right? Force in a perpendicular direction known as thrust, right? Per unit area, right? Per unit area means divided by area. So guys, that's why you can see the pressure formula, as you can see here, is going to be thrust divided by area. Excellent guys, clear? So thrust means, this guy means it's a perpendicular force, right? So perpendicular force. So to visualize it, guys, look at this picture here. So you can see, let's say this is like a rod, right? This yellow colored thing here, right? Let's say this is like a rod, right? Or a block that you're using. So you're applying a force here, okay? So we are applying a force, right? So we are applying a force on this rod against, let's say, this table here, right? The green guy is the table, okay? So what is the pressure? So clearly this force will get transmitted onto the table, right? So when you apply a force here, guys, do you guys agree that there will be a force on the table? Okay, right? And now the question is this force perpendicular or not? Is it perpendicular to the table? What do you guys think? And I want all of you to be very interactive here, and please write on the chat. So guys, is this force, is this a thrust? Is it a perpendicular force? What do you guys think? Okay, very good. I see Nevedita is saying yes, right? RK Semwal, you're saying yes, very good. So guys, you can see from the picture here, clearly the angle is 90 degree, right? So can you see that this rod over here is 90 degree, or it's basically, right? So it's right angle to the table. So clearly this force we can say is basically a thrust, right? And to calculate the pressure, we need to divide this force or thrust divided by the area of contact. So by area here we mean it's the area of contact, right? Okay, so the area of contact. So when you're taking this pencil, right? So guys, when you take this pencil and you press it against your palm, right? So guys, look here, if you take the pencil and look here, I'm holding up the pencil and you press it against the palm, right? So force F is the thrust or the force, the perpendicular force that you're applying, and then divided by the area of contact. So the area of contact of the pencil, so right, of the pencil and my hand here. Similarly, here will be the area of contact of the rod and the table. So this part, right? So this part is going to be our area of contact. Do you guys see that? Excellent. Is it clear? So that is what is the definition of pressure. This is the physics or scientific definition. Thrust divided by area. Very simple. But guys, don't say force by area. You might see that in your books. That's a simplification where maybe they're ignoring it, ignoring the perpendicular part of it. But basically the proper definition is the perpendicular force divided by the area. So we say thrust by area. Clear, guys? Fantastic. So now you know what is the concept of pressure, and right, it's so which one here is basically thrust? So which one do you guys think here is thrust? So I've got two pictures here. Can you guys see? So this is picture number 1, case number 1, and case number 2. And in both these cases, the force is being applied like this. So guys, which one do you think is thrust? The first one or the second one? Excellent, guys. Excellent. I see most of you have replied. Very good. The correct answer is, clearly you can see this is the thrust, right? Because it is 90 degree, right? So we can call this force as thrust, right? Because the angle is, can you see, this is the 90 degree angle. So this force is clearly considered the thrust. But then what about the first case, guys? So clearly a force is being applied. So here in this case, what will it be? Pressure will basically be force by area, right? So force means the thrust here, right? So we can say force, or I can write it as thrust, okay? Thrust divided by the area of contact, A, right? So the area, this area of contact, right? But what about the first case? Does that mean there is zero pressure here? So what do you guys think? Is this zero pressure or no? In the first case. So what is the first case? Try to visualize this. So if you take a pencil, right, and you hold it against your palm, but now you're holding it at an angle. It's not perpendicular. So when you press it, definitely you feel some pressure, right? You can try this yourself. Guys, please try it out, right? With a pen or pencil, right? So just pick up a pen or pencil and hold it against your palm and check, guys. That can you feel the pressure? Yes, you can, right? So definitely it's not zero pressure. So I'm going to erase that. It's clearly not zero pressure. But then how do we calculate it? Okay. So what is the thing here is that we are going to split up the force into a vertical component, right? So the force is basically going to be divided into a vertical component and a horizontal component. So let's call that a horizontal and a vertical component. So definitely there will be the vertical part is acting downwards. So this part is contributing to our thrust. So do you guys agree? Because horizontal is, right, it's on the it's along the table, but we are interested in the perpendicular force because we want to calculate pressure. So the perpendicular so the pressure is basically going to be the vertical force or the perpendicular force divided by the area of contact. Do you guys agree? Right? So that's how we, very good, excellent, great to hear, it's clear. And guys, if you haven't hit the like button, please hit the like button right now and do share it out with your friends. Guys, as I told you, we are at 199k subscribers and it's all because of you guys, right? So big thanks to all of you. We are getting close to 200k subscribers on Manocha Academy, and I want to say a big thanks from the team. Okay, so guys, if you take a look here, the pressure is FV by A. But in this class, we're not going to go into the details of how do we calculate FV. So the vertical component and horizontal can be calculated using trigonometry, right? So you can use the theta component. So there's going to be a sine theta, cos theta, but I'm not going to go into that in this class. So just for your concept, you know, and usually in the simple case, we basically use case 2. So if it's not given, we assume that the force, right? So if it's not given, we will assume that the force is perpendicular, so it will be a thrust. So this is usually our case, right? But of course, in real life, you can have the force at an angle which is not 90 degree. So here you can see the angle is definitely not 90. If you look at this angle or this side angle, right? So the angle clearly is not 90 degree, right? So therefore you have to break it into a vertical or horizontal component, right? And the pressure will be vertical component by the area. Excellent, guys. So is that clear to you, right? And so now let me ask you, so now you know what is pressure, right? Pressure is thrust divided by area. Guys, can you tell me what is the SI unit of pressure? So here's the formula for you, right? And as we talked about, the force is applied this way. So this perpendicular force, right? So sometimes you can use the label F. Usually we don't use T, we use F, right? So we are just going to assume that our thrust is perpendicular. So it's basically going to work out to be F divided by A. So come on, guys. Excellent. I see a lot of you are writing the correct answers. Superb, guys. Very good. So here our pressure is going to be force, the perpendicular force or thrust divided by the area of contact. So this area, right? The contact between the rod and the table. And what is the unit? So if you don't know the units, you can easily derive it from the formula. So guys, what is the unit of force? The SI unit. So you know the SI unit is Newton, right? Written with capital N, or Newton you write in small letters, right? And divided by, right? What is the SI unit of area? Come on, guys. What is the SI unit of area? Can you tell me? You guys are awesome. Super. I can see a lot of answers here on the chat. So come on, guys. What is the SI unit of area? Excellent. Excellent. Meter square, right? So it's basically the SI unit of force is Newton per meter square. Sorry, pressure, right? So the SI unit of pressure is basically Newton per meter square. Do you guys agree? Right? And this is given a special name, as you guys already wrote. So you guys rock. Awesome. So it's also known, this unit Newton per meter square is given a special name, Pascal. So usually the scientific convention is to write it in small letter, right? It's after the scientist called Pascal, and then we write the abbreviation in starting with a capital. So PA. Okay. So guys, note that the full name is usually written in small letter and the abbreviation starts with a capital letter. So very good. So you can say the SI unit is Newton per meter square, or typically you should be writing Pascal. So whichever one your school is using, so Pascal is usually used. Okay, PA, not P, right? So the unit, SI unit is Pascal. Excellent, guys. So now how do we define 1 Pascal? How much is 1 Pascal, guys? Right? So how do you define 1 Pascal of pressure? So what do you guys think? Come on. I want all of you to try here. And guys, if you haven't hit the like button, please hit it right now and do share it with your friends. And great, guys, thanks a lot for all the likes and all your love and support. So how do we define 1 Pascal? Very simple. If you look at the formula, right? So just use the formula. What is the formula? Pressure is thrust, or I'll just now write, we are assuming perpendicular force. So usually we write force by area, right? It's basically thrust by area, right? So what is 1 Pascal? Very simple. So 1 Pascal is basically, you can think 1 Pascal is going to be when you have a force of, let's say, 1 Newton, right? Divided by an area of 1 meter square, right? Very good. So that's the simple way of defining. 1 Pascal is basically when we have a force, right? When the force of 1 Newton, right? Or better to write perpendicular force, right? So perpendicular force or thrust, right? So perpendicular force, or correctly speaking thrust, right, of 1 Newton, right? So if your school is particular about writing thrust, you should write it because that's the proper definition. So thrust, right? So we can write it directly right as that, right? So let's erase all this and just write directly thrust of 1 Newton acting on an area of, right? So acting on an area of 1 meter square, right? Then we say the pressure is 1 Pascal, right? Simple. So very easy to see from the formula. It's basically 1 Newton by 1 meter square. Excellent, guys. Is it clear? So now do you have a feel, guys? How much is 1 Pascal? Can you guys tell me? Is it a very small pressure or is it a large pressure? So guys, can you tell me, is 1 Pascal, is it a large pressure or is it a small pressure? What do you guys think? Okay, and again guys, we're not talking about exam pressure, test pressure, work pressure, peer pressure. We're not talking about that. We're talking about physics pressure. Okay, please remember, force or thrust by area. So is 1 Pascal small or large? So some of you are saying small, some of you are saying large. Come on guys, what do you guys think? 1 Newton, so a thrust of 1 Newton on an area of 1 meter square. Okay, so to help you decide the answer, is it small or big, let me give you a very simple example. Okay, so let's say you take a 50 rupee note. Okay guys, so let's say you take a 50 rupee note, or if you're in the US, if you take a $1 bill, right? So if you take a $1 note or a 50 rupee note, okay, so guys, if you take a note like this, 50 rupees or 100 rupees, right, and you take it and place it on the palm of your hand. Okay, so guys, take that note, the 50 rupee note, can you guys see it here? Right, I'm holding it up right here. Okay, and you take that and place it on the palm of your hand like this. Okay, so you place it on the palm of your hand. Now the pressure that you feel on your hand, to give you a visual feel, right, to give you a feel of the pressure, that is 1 Pascal. Okay guys, so the pressure this 50 rupee note or a $1 note is applying, a $1 bill is applying on your hand, is just 1 Pascal. So excellent guys, now I see everybody's writing it's a very small pressure, because it's such a light thing with an area and you can hardly feel it on your hand, right? So it's a very, very small amount of pressure. We're not talking about the force, the pressure that you feel on the entire palm, right? It's divided by the area of contact. Excellent guys. So guys, do try it out. You can even take a 10 rupee note, 20 rupee note and place it on your hand. It'll give you a rough feel of the pressure. So guys, remember this. So take something like, a 50 rupee note, okay, and right, and place it on the palm of your hand, right? Place it on your palm, and the pressure that you feel is basically 1 Pascal. So it's very, very small, right? So it's very small pressure, and that is why usually in physics we use kilopascal, megapascal. Okay, so guys, that's why we tend to use 1 kilopascal, because this is a very small pressure, right? And so usually we deal with larger pressures. Of course, if the pressure is small, you'll use Pascal, and 1 kilopascal is 10 to the power 3 Pascal, right guys? Okay, so great to hear that now you're clear about what is 1 Pascal. So guys, we've been talking about force, pressure. So what is the difference? So what is the difference between force and pressure? So if you try to make a difference table between force and pressure, what do you guys think you're going to write? Okay. So guys, what do you think will be the first difference? So first difference can be very simple, right? We can simply say the first difference is the definition. Okay. So the first difference is the definition. So what is the definition of force? Remember, we discussed in a previous class, or you can watch my videos, right? So it's a push or pull, right? So force is defined as a push or pull, right? And what is the definition of pressure, right? So pressure, as we discussed, is thrust, right? So let me use a different color for pressure here, right? So pressure, as we discussed guys, is thrust per unit area, right? So thrust per unit area, perpendicular force per unit area. So for the first point, basically we are using simply the definition. Okay guys, excellent, right? And what is another simple difference? So we are comparing force and pressure. Another simple difference is the unit. Force, the SI unit is Newton, right? And what is the SI unit of pressure? We just talked about it, Newton per meter square, or basically Pascal, right? So Pascal is the, right? And so basically for this second point, we are using the unit. So let's write that down. So for the first point, we use the definition, guys, right? So for the first point, it was the definition. For the second point, we are using unit, right? Okay. And guys, another difference, can you tell me, is force a scalar or a vector? Okay, some of you are asking, what's my name? Guys, my name is Sandeep Manocha. So and guys, do subscribe to our channel Manocha Academy, and do hit the notification bell. And guys, also do check out our website. We have these awesome courses on physics, chemistry and maths, where I take more live classes. There are videos and quizzes and questions. So guys, do check it out. So come on guys, can you tell me, is force a scalar or a vector? Fantastic, guys. It's a vector, because force, you know, it has a direction. Okay. And guys, what about pressure? Is pressure a scalar or a vector? What do you guys think? And you guys are being awesome, very interactive. I'm seeing the chat full of answers, and it's making me really, really happy to see everyone involved in the live class. Awesome, guys. So is pressure a scalar or a vector? And for those of you who are new to this live class, welcome, guys, welcome. Please join in and give some answers. Come on. Excellent, guys. So pressure is a scalar, right? That's a bit confusing to remember, you know, because it's thrust or force per unit area, right? So why is it a scalar? So actually, you can remember that with a simple example, though we are not going to be talking about liquid pressure today, but you know, a liquid exerts pressure in all directions, right? For example, I have this glass of water here, right? So I've got this glass of water, and you know, water not only exerts pressure downwards, it also exerts pressure on the sides of the glass. So guys, can you see this glass of water here in front of me? The water exerts pressure at the base of the glass and also the sides. Similarly, you know that if you take a plastic bottle of water and if you puncture it on the sides, water comes out with the pressure, right? So clearly pressure in liquid acts on all sides. So what direction will you give it, right? Is it only downwards? No. You know, in a liquid, the pressure acts in all directions. So that way you can remember this with the help of the liquid example, that pressure is a scalar quantity. It does not have a direction, right? Though guys, we won't focus on liquid pressure today because we are focusing on pressure for solids, okay? But please remember, it's a little confusing. Pressure is a scalar quantity. Excellent, guys. Awesome. So now let's take a look at this question. Find the pressure on the base, right, of this box, right? So do you see this box here? The mass of the box is given as 5 kg and the dimensions of the base are given as, so you can see here, 50 cross 20 centimeters, right? So 50 centimeters times 20 centimeters. So come on, guys, I want all of you to pick up your pen and paper and try this question. So guys, come on, don't do it mentally. Please try it on a pen and paper. And guys, do hit the like button right now. So come on, guys, I want all of you to please hit the like button and go ahead and try this question. So pressure will definitely act downwards, right? Because here we are saying on the base of the box. So this is the base, guys. So let's mark out what we've been given. So basically we know the mass, right? The mass of this box is given as 5 kg. Can you see it's written here? 5 kg. So the mass is 5 kg and the force is definitely going to act downwards, right? The force is due to the weight of the box. So we know the force is acting downwards, right? So the force will be acting downwards, and the dimensions of the base. So they are basically 50 centimeters, right? So this side is 50 centimeters here, right? So we can say the length and breadth, and this one is 20 centimeters. Guys, do you see that? Okay. So what do you think is going to be the pressure? Okay, good to see some answers here. Come on, guys. I want all of you to try. So what do you think is going to be the answer here? So basically, let's use the formula, right? What do we know the formula of pressure? So pressure is basically thrust or force, right? Perpendicular force divided by the area of contact. Okay. So what is the force here, guys? So let's do it step by step. So come on. So guys, what is the force? So what is F here? So F, you know, guys, is the weight of the box, right? It's not the mass, because you know force is the weight of the box. Okay, so how do you calculate weight, right? So weight is basically mg, mass times the acceleration due to gravity. Okay, so we are going to assume the acceleration to gravity to the approximate value of 10 meters per second square. So basically we are getting 5 kg, right? All in SI units multiplied by 10 meters per second square. So guys, do you agree with me? Please check, right? So the force or the weight is basically going to be 50 Newton here. So do you guys agree? Our force is 50 Newton. Okay, and let's calculate the area of the base, guys. So the dimensions are given 50 centimeters cross 20 centimeters. Okay, 50 centimeters times 20. So area is going to be basically 50 centimeters times 20 centimeters. But you know that we need to convert it into SI unit, right? So 50 centimeters, nothing but half a meter, right? So 50 by 100. So basically this is 50 by 100 meter, right? Times 20 by 100 meter, because right, 1 centimeter is 1 by 100th of a meter. Guys, do you agree? Okay, excellent. So now basically what we get, if you multiply those and cancel it, I think these zeros are going to go, right? So this 0, and so basically there's a 10 and a 0. So I think I'm getting area of cross section is 1 by 10 meters square. Do you guys agree? Okay. So what is the final pressure going to be, guys, of this box on its base? So be careful, don't substitute the 5 kg, that was the mass. We need to multiply it by the acceleration due to gravity. We are finding the weight. So guys, what are you getting as the pressure here? Please calculate. So pressure is going to be force by area. So that works out to be, guys, so pressure, let's do it here, force by area. So that's 50 Newton, right? I'm substituting this value, 50 Newton divided by the area is basically, so we have divided by 1 by 10 meters square, right? So 50 divided by 1 by 10. We can leave the units because we are all in SI unit now. So what is the answer? Excellent, guys, excellent. I see General Master has written 500, Srinivas, right? Don't forget the units, guys, Pascal, right? So very good. So Sri Devi has written 500. Very good, guys. So we are basically getting P is equal to 500. 5 divided by 1 by 10 Pascal. So let me write the answer clearly here below, right? So the final pressure F by A is going to be 500 pascals. So please check if my answer is correct, guys. So this is how you calculate it. Okay. So force, right? The thrust divided by the area, and the trick is, guys, make sure you multiply with the acceleration due to gravity because you need to find the force, the weight, okay? And also don't forget to convert the centimeter to meter. Units are super important in physics. You need to be in SI unit. Excellent, guys. Very good. And don't forget to write. So some of you I'm seeing in the chat, you're writing 500 PA. Please, guys, don't forget the unit. Excellent. And P with a capital, A with a small. Superb. Great to see the answers. So now, guys, can you tell me, suppose you change the position of this box, right? So you can see this is, let's call this, the box is placed in this position, right? And let's say we sort of turn the position of the box and now it's in this position. So in which position of the box the pressure is more, or do you think it's going to be the same? What do you think? So is it going to be the pressure is more in position 1 or 2, or is it going to be the same? What do you guys think? Okay, and again, guys, just to give you a reminder, pressure is the thrust, right? The force or the thrust per unit area. Okay, so guys, come on, I want all of you to try and do hit that like button right now. And if you haven't subscribed to our YouTube channel, please subscribe and hit the notification bell so that you don't miss a single video or the live classes that we have here. And as I said, we are having more live classes on our website, manochaacademy.com. So guys, do check it out. Excellent, guys. Excellent. I see a lot of answers here. So do you think it's going to be the same or it's going to be more? So let's analyze. So in both the cases, the weight of the box, right? The force is basically the weight. So the weight of the box is same. Whether it's in this position or that position, that doesn't matter, right? So the weight of the thrust here is basically going to be the same. But you can see the area, right? So area of contact, let's shade it with this. I'm going to use, let's say, purple color here, right? Because we have orange on that box. So let's say this is the area of contact in this case, right? So in position 1, this is our area of contact. Do you guys agree? This is basically the area of contact A. And in this position 2, this is the area of contact. So the box is placed on the table like this. And now we are deciding on which case the pressure is more. Okay. So guys, can you clearly see? So let's call that A1 and A2. So guys, can you clearly see that A2 is less than A1, right? Because it's on this kind of blue side, right? Opposite. So don't be confused by the colors, guys. You know, maybe I should have colored it all the same, but you can see, let's take some dimensions here, right? So can you see, guys, that this one we had taken, 50 centimeters and this was 20 centimeters. So when you look at this case, it's basically lying on, and let's say this, right, this part was 10 centimeters, okay, the height. So can you see it's lying on the 10 and 20 end over here, right, guys? So can you see it's lying on the blue side, right, opposite to the blue side, which is 10 and 20. This side is 50. So clearly the area of cross section, this is, sorry, let me label it correctly. This is 10 here, right? So this side is 10 and this side is 20. So clearly you can see, guys, here the area of cross section, if you're even using centimeter square, it's basically 200 centimeters square is A2. So A2 is 200 centimeter square, and in the case of A1 it's basically 50 times 20, right? There it's 20 times 10, and in A1 it's basically 1000 centimeter square. 1000, sorry, not 100. Right guys? So clearly excellent guys. So basically the area of cross section is smaller, right? The area of contact is smaller. A2 is less than A1, right? Excellent. A2 is less than A1, therefore P2, the pressure on the second case, is more than P1. So the answer is the pressure in the second case is more, right? P2 is more. Superb guys, very good. So I see Kirit has the right answer, Satya, right? Aruna, very good guys. Jay Saran, superb. So second is because pressure is thrust by area. So what are we learning? That pressure is inversely proportional to the area. Pressure is of course directly proportional to the thrust, right? Because you can see it's in the numerator. So pressure depends on these two factors, the thrust and the area. And you can see since it's in the numerator, pressure is directly proportional to the thrust and inversely proportional to the area, because if area increases, it's in the denominator, pressure will decrease. Excellent guys. So is that clear? So let's move on to this question, right? So this is a very famous question in physics. Why is it easier to cut with a sharp knife as compared to a blunt knife? So what do you guys think? So when you take when you buy a new knife, right? A new or a sharpened knife, why is it easier to cut a lemon or an orange or a fruit? What do you guys think? So come on guys, this is a very famous question and I've seen it often being asked. Why do you think it's easier to cut with a sharp knife as compared to a blunt knife, right? So please understand, let's say you're applying the same force, right? So if you're comparing two knives, okay, let's say you have two knives, right? Knife 1, okay, so guys, let's say you have two knives, knife 1 and knife 2, okay. Now the first knife, let's say, is sharp and the other knife is blunt, right? So right? So what do you so since the first knife is sharp, right? Basically, what is the key thing here? The area, right? Because in a sharp knife, you know, the area is going to be less, right? So the area of contact is less. And in a blunt knife, because it's become blunt, the area is more, even though the area is small, but it's definitely more, right? So very good. In the sharp knife, very good. I see Chaitanya is writing less area, right? Excellent guys. So it's going to be due to less area. And now let's say that you're applying the same force. Let's say with your hand you're applying, just to make it easy, imagine if the force is same, right? So if the force is same, then which one will give more pressure? Clearly the sharp knife, right? So in this case, the pressure will be more, right? Or we can say that, let's say we want to cut with the same pressure, then we need less force, right? Because clearly when the force is same, clearly the pressure is more in the sharp knife. Or we can change the thing, let's say we want the same pressure, right? While cutting we need the same pressure, then the force required for the sharp knife is less, right? We need to apply less force. So main key thing is, guys, to write that area of contact is less. So what are the key things here? Area of contact is less, right? So area of contact is less, and please don't forget to write that the pressure is inversely proportional, right? Pressure is inversely proportional to the area of contact, right? And that's why when the area is less, the pressure is more. Excellent, right? So don't forget to write this, and this, you know, 1 by A, this basically means what I've written here is the term inversely proportional. Right guys, inversely proportional. Clear? Excellent. So this is why it explains that when you have a new knife or a sharp knife, how easy it is to cut. And when the knife gets old or blunt, then we need to get it sharpened. Okay. Another question, right? And this you guys must have experienced, right? When you carry your school bags, you know, and it's full of books and all, right? You know, the school bag feels heavy. So why do the school bags have thick shoulder straps? So come on guys, can you tell me this answer? So this, I think you've experienced in your daily lives, right? That when you take these, your school bag, or let's say you're going on a trip and you carry a bag, right? You prefer the one with thick shoulder straps. Why? So can you see here? The shoulder straps are thick here. So thick straps in this picture, right? It's not that the straps are thin like this, right? So we don't have, like this would be an example of a thin strap, right? If you had something like this. Here you have thick straps. Why guys? Come on. Excellent, excellent. I see all of you are writing the correct answer because thick straps clearly means that area is more, or area of contact you can write, right? So area of contact or area is more, right? And again, you know, pressure, the formula is pressure is force or thrust divided by area, right? Area of contact. So therefore we can clearly say that pressure is inversely proportional, right? So pressure is inversely proportional to the area. And so therefore, since the area of contact is more, we feel less pressure on our shoulders, okay? Because let's say you have to take all your books, right? So you can't say that, no, I'm not going to carry these books or these things in my bag, or when you're going on a trip, you're taking certain things. But now when you wear the bag, it's much more comfortable, because since the area is more, the pressure we feel, so pressure we feel is less, right? We feel is less. Right? And you can check this when you're carrying, you know, a packet which has very thin straps or thin handles, or a plastic packet. It feels very, you feel a lot of pressure. You know, sometimes you feel, you see red marks on your hand because of the high pressure, because the area of contact is less. But when you're carrying even something heavy like this, you feel less pressure. Excellent, guys, excellent. So please relate your science, right? Relate your science with your everyday life, then you're going to enjoy it. So make the connections, guys. Superb. And similarly, now I think this should be easy for you. Why do tractors have white tires? So great to see the response and that all of you are understanding the concepts. So guys, why do you think tractors have white tires? So can you see the picture of the tractor here? So this is the tractor, right? In this picture, and can you see the tires are huge? Can you see those big, thick tires? It has wide tires, right? If you compare it to the tires of a bicycle or for a car, because they have much wider tires, okay? So why do you think? No, guys, this is not to do with the friction here, right? This is nothing to do with friction. Here we are focusing on pressure, guys, okay? So because, why does the tractor need that? So you can see again, as you guys are correctly saying, when you have wide tires, the area is going to be more, right? So area is clearly more here, okay? And so when the area is more, definitely we know that pressure is inversely proportional, okay? So pressure is inversely proportional to the area of contact. So clearly the pressure is going to be less. But guys, can you tell me, why do we need less pressure for tractors? So, right? Why do you need less pressure? So absolutely right, that the pressure, let me write that clearly. So pressure is going to be less because the area is more. So why do you need less pressure for the tractors? Okay? Because remember, guys, where are tractors moving? Do you see the tractors on roads? Okay, where do tractors actually move? Okay, excellent. I see Namita is writing the right answer, right? Animesh, very good. Because otherwise, because you know the tractors are not moving in the streets and the roads of the city. They are moving on the soil, guys. Excellent. So you can see they are moving on soil or soft ground, right? So they're moving on soil or soft ground. Can you see that in the picture here? Right? And therefore, basically, right, they're moving in the farm on the soil, otherwise on soft ground, otherwise the tractor tires will sink, they'll get stuck. Absolutely right, guys. Okay, so I think you can't see this thing, so let me write it again here. Soil or soft ground, as you can see, right? Absolutely. Otherwise, very good. Otherwise, they are basically going to get, so the tractor tires will get stuck, right? So the tires will sink in the ground. So tires will sink in the ground, or they will get stuck in the ground, right? Sink in the ground, or they're basically going to get stuck. Because if you have too much pressure, and please note that the tractor is heavy, it's not a light thing, right? So the weight of the tractor is huge, right? We are doing that because the weight, please understand, the weight is large, right? And so we don't want, and you know the pressure is basically the weight, right? Force or the weight here. So in this case, it's basically the weight divided by the area of contact. Since the weight is large, you want the area also to be large so that the pressure is less. Clear? Otherwise, excellent. It will sink in the ground. Superb, guys. And similarly, guys, why do you think tanks rest upon this continuous chain? So I'm sure you've seen these pictures or you've seen it in the movies, right? So in the war movies, you've seen that these tanks are moving on these large, thick chains, right? So can you see here? There's this continuous chain. So I'm marking it with the dotted line here. Let me mark that again. So these tanks have these continuous chain. Can you see that? Going all the way around. Maybe you can't see it in the grass here, but can you see? Again, this is that long, continuous and the thick chain. Can you see that on both sides? So why the tanks are using this continuous chain, right? Okay, what do you guys think? Right, very good. So Animesh is saying they're called caterpillar tracks, right? So these are sometimes known as caterpillar kind of things. You've seen it in those caterpillar cranes also. Okay, so excellent, excellent, right? So because again the continuous chain, so that the area of contact, so these are not simple tires, right? It's a long continuous chain. It's like a flat thing, right? So the area of contact you can see is all of this part, right? Right, and with that width, so this is the area of contact here. Can you guys see? So let's mark it clearly here. Oops. So let me mark that clearly here, guys. So this is the area of contact. Okay, so the area of contact is going to be very large here, right? And again, guys, the tank is massive, very heavy. The weight of the tank is huge. So if you think about, the weight of the tank is also very large. And again, excellent, guys, because more area of contact, you know, the pressure is inversely proportional to the area of contact. Okay, and so the weight of the tank of course is large, so more area of contact means the pressure is going to be less. And again, you know, guys, that the tanks are not just moving on, you know, tarred roads. They are basically moving sometimes on soft ground in various terrain. The tanks have to work on many different terrains, right? Soft, hard, right? So basically they don't want the heavy tank to get to sink and get stuck, right? So we don't want the tank, right? The tank should not, right? The tank should not get should not sink in the ground, right? Sink in the ground or get stuck, right? Same thing, just like the tractors, they should not sink in the ground, should not get stuck, right? And that's how we do it, because we are reducing the pressure. Okay, so excellent, guys. So see, all these concepts we've used the concept of pressure, and it's different from force, because what is pressure? Pressure, as we discussed, guys, pressure is thrust by area, right? So thrust, it's not just force. So don't think pressure is the same thing as force. No, right? It's thrust divided by the area. And remember, we discussed these differences here, right? So it's thrust per unit area, and the unit is Pascal, and it's a scalar quantity. So force and pressure are definitely not the same in physics, right? They are different physical quantities with different definitions, as you can see here. Okay, guys, so I hope the concepts are clear to you, and I have this interesting question for you as a homework question. A boy has a mass of 40 kgs. Okay, if the area of each foot of the boy is, let's say, 100 centimeters square, find the pressure on his feet, right? So you need to calculate the pressure on his feet when he stands on the ground. Okay, and guys, I'm looking forward to your answers, so please do write it in the comments below, and I'll try to reply to them as soon as possible. So this is an interesting sum for you guys to calculate based on the concepts that you've learned in this class. Okay, so do write your answer in the comments below. I look forward to reading everybody's answers. And guys, if you haven't checked out our website, please check it out right after this class. It's manochaacademy.com, and I'll put the links below, right? And you have these courses on physics, chemistry, maths, and we've got great discounts going on because we want everybody to sign up and benefit from these courses, right? So we have got physics, chemistry, maths for CBSE class 9, 10, and physics for ICSE class 9. I know we've been getting more requests to launch more courses. Our team is working on that. So guys, a big thanks to all of you. So guys, do share it out with your friends, and if you haven't subscribed to our YouTube channel, what are you waiting for? Guys, please hit the like button right now and click on the notification bell, that bell icon, so that you don't miss a single live class or the videos that we upload. So thanks, guys, for joining in. It was very interactive. I really enjoyed it because you guys were writing excellent answers and excellent things. Sorry if I couldn't, address each of your doubts or things here, but I've been always taking a look at the chat, and your response has been amazing. And guys, we have more live classes, so if you like these live classes, do join us in the live classes on our website. We have interactive videos, more quizzes and questions for you to practice, and you get direct replies from me on your doubts. Okay, so I'll put the links below, and thanks again for joining. This is Sandeep Manocha signing off. Guys, take care of your health, and please do share it out with your friends. Thanks a lot. So see you next time in the next live class. And so when is the next live class, guys? Please click on the notification bell. I'll try to take another one this week, or we'll definitely have another one next week. So guys, you'll get the notification on YouTube. So please subscribe and click on the notification bell so that you don't miss a single class. And thanks, Albert. Yeah, we are getting close to 200,000 subscribers, and it's all thanks to all of you guys. I want to thank each and every one of you for all the love and support, and we receive such great feedback and comments, and even suggestions from you guys. And guys, what topic would you like next? Please write it in the comments below. I know I may not be able to do each and every topic, but it does help us to know what topics would you like, right? And guys, do check out these full courses on physics, chemistry and maths on our website. Thanks a lot. So I really enjoyed it. Hope you liked it too. Guys, thanks a lot. Take care. Take care of your health during this difficult time. So here's Sandeep Manocha signing off. Bye guys. And do hit that like button. Thanks. Bye-bye.